before I even start talking about this unit, I want to express the expectation for this entire unit. If you want to write it down on your assignment sheet, if you want to write it down on your packet, I want to make this very, very clear right now. In the homework, if it says to graph, you graph. It's not optional. It's not like if I feel like it or not. Okay? If it says to graph, graph. If not, if you don't graph, no problem. I just don't give you the credit for it. Don't be lazy. Back of your packet, multiple sheets of graphs. All right, in the back of your packet, multiple sheets. So there's no excuses there that I didn't have graph paper. Or if you want actual graph paper, there's some right underneath in the shelf over there you want before you can take before you leave. Okay? But if it says to graph, you graph. Unless the assignment sheet, there are a couple nights I say the graphs are optional. Okay? But starting tonight, if it says graph, please graph them. All right? And you got plenty of sheets of graphs on the back. All right? We all good there? Drives me insane. All right, brand new unit. Taking a totally different turn from where we were last unit. Transformations. We've actually talked about all four of them. Reflections, rotations, translations, and dilations through the course of this year, but now we're going to get real specific. All right, really specific. Just some general vocab about transformations of a geometric figure here. Transformations that preserve lengths of segments and measures. Do we remember what we called those? I think I've used this term before. Like reflections, rotations, translations. If they don't change size or shape, they're both congruent to each other. We had a term for them. Rigid motions. Yep, rigid motions. Get used to that term this unit. That is any type of transformation that does not change size or shape of the figure. And there's one that does change size or shape, and that's a dilation. All right, but it won't preserve side length, but it does preserve what? Angle measure when you dilate. And the final two vocabulary terms, I don't know if you heard this back in the middle school or not when you did these units. Before I do anything, the original figure, before I do anything to it, the original figure, I'm going to call the pre-image. And then once I transform it, rotate it, reflect it, translate it, whatever I do to it, make it different, the resulting figure is going to be called just the image. All right, just the image. So I start out with the pre-image, I finish with my image. All right, do these appear to be rigid motions or not? To go from number one triangle to the other, does it appear like I did a rigid motion? A rigid motion occurred. Yes or no? Tell me why. Back yourself up. 4, start us off. Yes or no? Does that look like a rigid motion was performed? No, why not? Correct. Size changed. All right, so no, there's a change in size. So that a rigid motion did not occur. And again, we're just eyeballing it. Don't get crazy detail on me here. Number 2 here. Does it look like a rigid motion was performed? 29? Yes, it does. Why, Dan? Well, maybe not just, maybe I did something else other than a reflection, but what do you notice about their size and shape? Yep. Both figures are same size and same shape. All right. We're going to talk about one rigid motion for the next 3 days. Yes, 3 days, one rigid motion, and that is a line reflection. Line reflection. Why do I get specific and put the word line with it? Because you can actually reflect through a point too. All right, which we'll do later on in the unit. But all the next 3 days are consisting of a line reflection. All right, a line reflection. I'm not going to go through this definition right now. I'm actually going to use it when we start making these points down here. Notation. You don't want to write the word reflection every time, I'm assuming, correct? So there's notation. There's a symbol for reflections. and it is a lowercase r. A lowercase r. Don't put an uppercase. That's for later on in the unit. Lowercase r. Then you know what a subscript is? See that in science maybe? Not a exponent, but a subscript. That you'll see a subscript here, which tells us what line we're reflecting over. So the lowercase r with this y-axis below tells me this is short for reflection in the y-axis. All right. All right, let's do a couple of these. Let's reflect and reflect and reflect some more. All right, I have point A, which is 2, -1. All right, 2, -1. If you wouldn't mind plotting that, go right ahead. Point A, 2, -1. A lot of graphing in this unit, a lot of graphing. First thing I want you to do, lowercase r with the x-axis. What am I asking? Reflect over the x-axis. All right, it maybe been a while since you've done this, so I'm going to go slow. How do I reflect in the x-axis? Well, number one, distance is always preserved when I reflect. How far is it? How far is point A from the x-axis? 1 unit. So when you do the image of it, it should also be 1 unit away. All right, in the same direction. So I got 1 unit away. I go 1 unit in the other direction, and now I name that point right there. What is that point right there? 29 here, yep. Oh, easy there, bud. I'm not looking. You just stole my fire, thanks. But just looking for the coordinate of A. 2, 1. And yes, Dan just took away my next teaching moment, which was I can't call it point A anymore because point A is right here. So yes, Dan, we're going to call it A prime right there. Yes, A prime. And here's what I want to talk about right now. If you could, connect A and A prime for me to form a line segment. I'm going to get back to that definition I skipped over. What line did we reflect over? One more time, what line? X-axis. And if you take a look, anytime you reflect, the line of reflection, which line do we reflect over? Okay, the x-axis in this case. The line of reflection acts as the perpendicular bisector for this segment. Does everybody see A prime is being bisected perpendicularly? I don't even know if that's a word. By the x-axis. Everyone see that? Both 1 unit and it's perpendicular to it. The line of reflection always acts as the perpendicular bisector for those two. All right. Go down here. Now we're going to reflect it over the y-axis. A, we're sticking with point A. Don't go from A prime, go from A. So take A now and reflect it over the y-axis and let me know the point. Five. What's my new point? -2, -1. We're still going to call it A prime. All right, because we're just going back to A. And A, for you guys that are probably wanting to put A double prime, that's if I did something to 2, 1. Okay, if I kept going with 2, 1, I'd call it A double prime, which we will. All right, I'm going to skip over y equals x and come back to it last. Now I want to do here, y equals 2. Ooh. Anybody remember graphing lines? What type of line y equals 2 is? Don't tell me straight. All lines are straight. Y equals 2. Y equals 2. What type of line was that? Horizontal. Get used to it. Get used to this. Horizontal line going through 2. So if I drew it on my diagram up here, Should probably make that a little thicker. Y equals 2. This line right here. That's y equals 2. All right, distance is preserved. Count now. From point A to y equals 2, how many units am I going? How many units? 3 units, so I go 3 units in the other direction. 1, 2, 3. And now name that point. Be careful when you name it too. I always get worried when we reflect over horizontal and vertical lines. Make sure you count from the origin. Some kids will count right here and tell me it's got a y coordinate of 3. All right, make sure you count from the origin, please. What do you got for me? 11. What's that new point? 2, 5. Everyone all right there? If I said x equals a number, that would be a vertical line. All right, get in that habit. Y equals is horizontal, x equals vertical. And now what about this last one? Y equals x. Grab your calcs, ladies and gentlemen. Grab your calcs. You won't need it much this unit, but today and tomorrow a little bit. I want you to actually see this line we're about to reflect over. So if you can, go to your Y1 screen right now. Go to your Y1, Y equals Y1. Just type in Y equals X. That was it. Hopefully you haven't been messing around with your calculator too much, and it'll graph for you nice. If it says error, hit go to. That's because there's something else in Y whatever. There's crazy stuff in Y8 or Y10. All right. Everyone getting this line? Yes? All right, we're going to reflect over that line now. How do we do that, though? How do I take that point and reflect it through that line? Like, do I paint the dot and then I actually fold it over and see where that dot lands? No, I don't want to do that. We don't have time for that. Ready? Watch this magic. What's the equation we're flipping over? Y equals X. Ready? Let me say that again. Your Y coordinate is equal to your X coordinate. So really, 2, -1, where's the 2 going to go now? The Y is equal to the X. So now 2 is the X coordinate. It's going to become the Y coordinate. And your Y coordinate is going to become the X. So in a nutshell, when I ask you to reflect over the line Y equals X, what do I do in my coordinates? Flip them. Flip them. Don't change the sign. We just flip them. Now take a look. -1, 2. Go ahead and plot it real quick. Darn right. Looks like I just flipped over that line. Okay? So when I reflect over the line Y equals X, I just need you guys to flip them. All right? All good there. Not great, though. All right, next one. Now do a whole triangle in the y-axis right now. Whole triangle in the y-axis. Graph it and tell me A prime, B prime, C prime right now. Just count the distance from the y-axis, go that amount in the other direction. Name the points. Make sure you got the primes with them. All right, let's do this. When you're ready, let me know the new points. 12. Let's roll. New points. A prime. Darn right. B prime. Yep. Finisher. There you go. Okay. Make sure it's through the y-axis, not the x-axis. 1, 2, 3. All right. Questions from you guys at all? Not too bad. All right, now I want to get a little bit more hardcore. Okay, next one. Take 0, 5, call it point X. 0, 5, call it point X. And reflect that through the line X equals 2. Okay, X equals 2. What type of line you drawing? Vertical, going through 2. There it is. X equals 2. All right. Distance is always preserved. Count the distance, please. From X to X equals 2. What a distance are we talking about? Distance of 2. Go 2 in the other direction. 1, 2. Here's X prime. Name that point. Do not go from the line. Go from the origin. Yeah, I know that. Okay, well, a couple people are going to start going from the vertical lines. Go from the origin. What's my new point now? Woo, 8. Let's go. What do we have? New point? 4, 5. Yeah, I like it. Reading. Next one. Reflect what now? X prime. We're not going back to 0, 5. Slow down. Read it, please. Now take X prime and reflect it through y equals -3. What type of line? Horizontal line now. X equals y equals -3. There it is, right there. Oh, I'm so sorry. So sorry it fell off the graph. Cry me a river. All right. I think we could figure out where the point should be. All right. Sorry. Rough life, I know. First world honors kids problems. Yep. He didn't give me enough graph. That's fine. You don't have to graph it, but you can still get the coordinate from it. Without a doubt, you can get the coordinate. Because look, which coordinate's not going to change? The x or the y coordinate here when I reflect? The x coordinate's going to still stay 4. And then I say to myself, all right, well, how many units do I go from 5 to down to -3? I got to go 8 units. So think about it. I got to go 8 more units this way from -3. Where do I end up on the y-axis? 25. Wow. -11. Anything from you guys there? All right, FG. We just reflected a triangle. Now let's reflect a line segment. Lowercase r again, reflection. There's that line again, y equals x. Go back. What was the rule for y equals x? What did I have to do with my coordinates? Flip them, flip them, flip them. So now I'm going to take 3, 0, and it's going to become 0, 3, and I'm going to take 4, 3, and it'll become 3, 4. Let's graph those bad boys in. And I don't know if anybody's thinking, they look so close. It didn't look like we reflected at all. But remember the line. What's the line look like? Right through the origin with the slope of 1. Yeah, we did. We reflected it over that line. Absolutely. Part B, reflect FG. So going back to the original now. Going back to the original. Oh, how about this line? Y equals negative X. Hey, take a look. Y equals negative X. Here's the line we're going to flip over now. All right. Thoughts on what we're going to do? Well, Y equals X, we flipped them. Y equals negative X. Thoughts? Well, let me draw the line in, and then we can take some guesses. Y equals negative X. What do we think the rule is here? Y equals X, I was going to flip them. Now, well, it's still Y equals X, right? So I'm still going to flip them, but now attach an, I don't want to say attach a negative, but flip the signs. All right, so not only you're going to flip the order, you're going to flip the sign. So 3, 0 is going to become flip and negate. 3, 0 will become 0, negative 3. And 4, 3 will become negative 3, negative 4. There you go. Flipped over that line. And finally, the only other thing I need to show you is, can you find your own line of reflection? So I'll give you the pre-image, I'll give you the image. What line did I reflect over? So go right ahead, graph those two, and then say, all right, where can I draw a line in where distance does not change? Where can I draw a perpendicular bisector in? (16), that line of reflection. X equals 3. YX equals, not Y equals. Vertical line, all vertical lines are X equals a number, right? So line of reflection, which I'll abbreviate as LOR, x equals 3. Okay. Graph means graph. You can go ahead and get started on that. If you want actual graph paper, it's right underneath the helmet over there. Might as well do the entire homework on it if you're getting a sheet of graph paper.